In this module, we will cover benchmarking. As previously discussed, the purpose of collecting product documentation and performing life cycle assessments is to be able to compare the information to other products specifically or to the industry at large. One key process in standardizing these results is benchmarking. A benchmark is a reference value to which different performance metrics can be compared. These benchmarks are set by different departments of transportation to establish their criteria for performance and sustainability of new roadways, and scopes can range from the material to the project level. Product benchmarks are currently being developed for materials like concrete, asphalt, and steel. Another variation in benchmarks comes with the level of the agency setting these standards. Benchmarks can be set at the national level and all the way down to local levels. National level benchmarks use data from the entire country, which makes them more universal. However, they are often less useful to specific states and localities. For instance, while the national benchmark for half-inch nominal maximum aggregate size in asphalt mixtures might be 70 kilograms of CO2 equivalent per short ton of mix, it may be that in a certain state, these mixtures are usually produced at about 60 kilograms of CO2 equivalent per short ton because of regional advantages like close-by quality aggregate sources with lower asphalt absorption. Or it could be that in a particular locality, steel carbon emissions are lower than the national benchmarks because there happens to be a nearby steel supplier, which reduces transport emissions. Therefore, state and local agencies should consider setting their own benchmarks that reflect their conditions rather than rely on less relevant national benchmarks. With state and local benchmarks, each state or locality can more fairly compare carbon emissions against state or local competitors only. The utility of these benchmarks lies in the data that backs them. With enough representation, these standards can help establish carbon reduction targets that are relevant and effective based on the current state of the industry. When benchmarking embodied carbon, values are typically normalized based on the unit used in the associated life cycle assessment, such as CO2 equivalent per lane mile. Currently, roadway embodied carbon benchmarks are not yet widely developed, leading to a lack of data that drives the value of these processes. Once a representative sample of roadway projects is established, however, one that captures the variability of roadway classes and LCA scopes, descriptive statistics can be used to create and standardize these benchmarks. An example of a benchmarking effort comes from the Carbon Leadership Forum, which has already been involved in benchmarking carbon emissions for quite some time. In this example, the Carbon Leadership Forum performed a limited study on roadway life cycle assessments that captured the materials production and construction phases only, or modules A1 through A5. This figure summarizes the study results. The different projects they analyzed were broken down into a few distinct categories. Projects with bridges and tunnels, projects with a bridge or bridges, projects where the entire work effort was analyzed, and projects where just the pavement structure was analyzed. For each category, the plot indicates the average, the range that contains 50% of the data, and the extremes that were measured. As you can see, roadways that include bridges and tunnels create more emissions per lane mile than those without. You can also see that if one just considers the pavement structure and nothing else, the estimated emissions are significantly less than if one considers the whole roadway, by a factor of about 2. This highlights the need to understand the scope of analysis. In other words, what was considered and what was ignored when interpreting transportation project LCA data. With more data to be collected in the future, Benchmarking is a great way to standardize the results of these life cycle assessments and to provide a barometer for an industry's efforts in carbon reduction.